For this one, we are going to find our common denominator. What's our common denominator between 5 and 8? 40. You can do cross multiplication here too, by the way. It works out exactly the same. So if I multiply both of these by my common denominator, I'm going to multiply that by 40 and that by 40. I can cross cancel here. 5 cancels how? 5 and 40? 8. And then 8 and 40. Miraculously 5. So I have 8 times x equals 5 times this group. So I have to say 5x plus 15. Subtract your 5x over. You get 3x equals 15. So x is going to equal 5. For 5, your common denominator here, which again, you can cross multiply if you want to. This is just factored at x plus 1. That's all we have. This is x plus 1, x minus 1, right? So if I multiply both sides by my common denominator, x plus 1, x minus 1. X minus 1 there. On the left-hand side, my x plus 1 and my x plus 1 cancels, and I'm left with 3 times x minus 1. On the right-hand side, everything cancels, so I'm left with just 1. So I get then 3x minus 3 equals 1. I'm going to add 1. 3x equals 4. Divide by 3. X equals 4/3, which is what we have here. So let me do a cross multiplication then. So cross multiplication would give me 3x squared minus 3 because I distribute here. And then that equals x plus 1 there. So for this one, my common denominator, I'm going to look at 3x, 3 and 3x squared. My common denominator between my numbers is 3. Between my variables, I have x and x squared. And remember, you use your highest. So you're going to use 3x squared here. So I'm going to multiply everything by 3x squared. All right. This first one, 3x and 3 and one of my x's canceled, right? Here the 3's cancel, and here the x squareds cancel. So I'm left with 11 times x minus my x squared equals negative 12. All right, so I want to get everything to one side for this one. I'm going to move everything over to the right to get my leading coefficient positive. So I have 0 equals x squared minus 11x minus 12. All right, x minus 12, x plus 1. All right, so x equals 12, x equals negative 1. Extraneous means you check this. 12 and negative 1, neither will cause a problem. So that is why both are solutions. When the outcome of one event affects the outcome of a second event, the two events are dependent events. When the outcome does not affect it, they are independent events. That's pretty straightforward. They give you some examples here. Classify each as dependent or independent. Roll a number cube, then toss a coin. Nothing about rolling the number cube will affect tossing a coin. So they are independent. All right, pick a flower from a garden, then pick another flower from the same garden. These are dependent because you took away how many flowers you have to choose from. Dependent, all right? So A would be independent, B would be dependent. It's important because when you do multiple events, you have to know if your first event affected your second event. So if I were to choose randomly one person from this class, right, that would be 1 out of 11. But if I don't put that person back into my options and I choose a second person, my now options are 1 out of 10. So I have affected my second event. My first event has affected my second event. That is dependent. If I pick one person to do something for me, they come back, and then I pick a person and from the same group of people, those are independent. I have put that person back in the options. They are now, it's an independent event, okay? So suppose you select a marble from a bag of marbles, you replace the marble and then select again. Are those dependent or independent? Dependent. The important word here is the word replace. You replace the marble. You did not affect your second draw at all. Had you left the marble out, it would be affected. All right, think of it like a box of chocolates. If I take the chocolate, right, take the chocolate. I mean, I don't know if you do this, right? You break the bottom open and it's like an icky one you don't like, you put it back in. That didn't affect it, right? But you take the chocolate out and it's the chocolate truffle that everybody's like the gold mine trying to find. You eat it, you just affected the box of chocolates, right? So if you put it back, it doesn't affect it. If you keep it out, it affects it. So how do you find the probability? If the events are independent, A and B are independent events, then probability of A and B is just the probability of A times the probability of B. If they are dependent, then it's basically the same probability, but you have to start over with probability of B. So when I gave the example of the chocolates, if you have 12 chocolates, you take one, that's 1 out of 12, all right? If I eat it, I have to consider 1 out of 11 when I do that times probability of B. B has been affected, all right? Suppose your favorite radio station is running a promotional campaign. Every hour, 4 callers are chosen at random to select 2 songs each. You call the station once after 7 a.m. and again after 3 p.m. What is the probability you will be one of the 4 callers both times you call? Are these dependent or independent? So what is your probability of in the 7 a.m. hour being one of the people?
4 over 125.
4 is the possibilities that are what you want. 125 are all possibilities. And then the second time, what's your probability of the second time? 4 out of 200. By the way, when you multiply these, you can simplify them first, right? So you can cross cancel the 4 and the 200 because they multiplied straight across, which is really what you do. But I would actually reduce first. But when you reduce and get it, you get 2 over 3,125. If they want that in percentage, you would actually divide. All right, so divide those. What do you get when you divide those?
0.064.
It's 0.00064, right? If I want that percentage, then what do I need to do?
Move the decimal place on the right.
How many places and which way?
Twice to the right. 3 times. Twice.
Twice.
What percentage are you getting?
1,000.
Mutually exclusive. When 2 events cannot happen at the same time, the events are mutually exclusive. Mutually exclusive. Are these events mutually exclusive? Rolling a 2 or a 3 on a number cube.
Yes.
Yes, they're mutually exclusive. There's no way you can roll a number cube and it be a 2 and a 3. And don't give me the example that it's going to land on its little edge. All right? We mean that it like an actual valid roll of a die. Okay?
I don't think 2
So-
and 3 are on the same.
They are mutually exclusive because you can't roll 2 numbers at the same time. Rolling an even number or a multiple of 3, are those mutually exclusive?
Yes.
Really?
Wait, I take it back.
So it's not mutually exclusive because I can do that at the same time. I can roll an even and a 6 at the same time. Okay? So are these exclusive? Rolling an even number and rolling a prime on the number cube, is that mutually exclusive?
No. Oh, yes. That is
The next one is rolling an even number and rolling a number less than 2. Are those mutually exclusive?
Yes.
Yes. The only number less than 2 is going to be 1, and that is definitely not even. Those are mutual. All right. If A and B are mutually exclusive, then you can take the probability of A and just add the probability of B to see the overall probability. You can just add the 2. If they are not mutually exclusive, you add the 2 and then you subtract the overlap, somewhat like we did at Bellwork, okay? You add the 2 and then you subtract the overlap. So like if we were doing the even and the, or the multiples of 3 and the evens, okay? How many evens do I have on here?
6.
3.
3 out of 6, right? And how many multiples of 3 do I have on here?
2.
2 out of 6. I'm going to add those, and then I will subtract my overlap. How many overlap? Even and 1 out of 6. All right, and that would be my probability. Does that make sense? All right. So, about 53% of U.S. college students are under 25 years old. About 21% of U.S. college students are over 34 years old. What is the probability that a U.S. college student chosen at random is under 25 or over 35? Are those mutually exclusive? Yes, a person cannot be both under 25 and over 35. That's just strange, right? So if I want to find these probabilities, I'm going to take the probability of the first. We're going to leave it as this, but because we're adding, we're going to change it to a decimal, 0.53. We are going to add it to the probability of the second one, which was over 34, 0.21. And I am going to get 0.74, or if I convert that to percentage, back to 74%. To do from 25 to 34, you should have gotten 26%.
Yes.
25 to 34 or over 34, 47%. And under 34, 79%. So, if I were to think of it that way, I would say, well, under 25 is going to be my 21%, right? Over 34 is going to be, oh, yeah, I did it backwards, didn't I? Thank you. This is 53%. This is 21%. All of it must add up to what?
100.
Yeah, it must add to 100%. All right. And so you can think of it in blocks. This block here in the middle is going to be your 26%. And then you can just go from there. These are mutually exclusive, so you can just add those. This is going to be everything this way, and you can just add those.
Jelly beans one.
Suppose you reach into the fruit bowl at the left and select a piece of fruit at random. What is the probability that the piece of fruit is an apple or green? The first thing we decide is that mutually exclusive, apple and green?
Yes. No. There's green.
Not in this bowl, there are green apples, okay? And so that is not mutually exclusive. So we're going to say the probability of an apple. We are going to add that to the probability of a green fruit, and we are going to subtract from that the probability of it being both.
Because there are
There
also,
are 3 green fruit.
there's also
All right.
like
Three green
a line.
There's a lime in there, right? So what's the probability of the... So first of all, how many pieces of fruit do I have in the bowl?
9.
How'd you count that fast?
9.
Great.
All right.
We should-
How many apples do I have? I have 5 apples.
Oh, stop cheating.
All right. I still have 9 pieces when I'm looking at green. How many pieces of green fruits, right? And how many green apples do I have? 2. So 5 plus 3 minus 2 gives me 6,
Over 9.
which I do reduce, by the way. 2/3. If they did it in percentages, it would be what, 66%ish. So whatever. I believe they left it as a fraction though.
Why is there a line in the fruit?
5. So you have 5 apples out of 9. You have 3 red fruits out of 9, and then you subtract the crossover. There are 3 red apples. So you end up with 5 over 9. All right? Green. How many green fruits do you have?
3.
3 green fruits out of 9. How many citrus fruits do you have?
4.
4 citrus fruits out of 9. How many crossovers that are green and citrus?
1.
1. So you have 3 plus 4 minus 1. What do you get?
2/3.
Yeah, 6 out of 9, which gives you 2/3.
66.
So